All right, Miss Julie, it's all you.
All right. So today we're going to do kind of like a STEM lesson. And I know it's kind of weird because, we're not around each other. So I'm going to do my best to show y'all kind of like what's happening. So if it's not on me, that means I'm like kind of showing the M&M. So we're going to do an M&M like science experiment. So when we do science experiments, there's a thing called scientific method that you follow. So we have where you make an observation of something. So you look around at your surroundings. So I have a box of M&Ms, and then I have my water I'm going to use. And then I'm actually going to use a mouthwash cup. So if you happen to have these supplies, you can use any size cup that you want. It just has to put water inside of it. So after you make your observation, then we're going to form a hypothesis. So I know some of you may know what a hypothesis is. Does anybody want to try to guess or answer what it is?
It's when you try to guess what's going to happen before it happens.
Yes, very good, Aiden. You make a guess, an educated guess of what you think is going to happen. So before we start, that's what we're going to do now. So I'm going to put my water in the cup. And what we're going to do is we're going to put the M&Ms inside the water. So does anybody want to guess what they think is going to happen to the M&Ms?
The M&Ms might lose its color.
Might lose its color. Very good. Is there any more guesses?
Turn colors.
Turn colors. Yes. Very good. Okay, so I will tell you what's supposed to happen is on an M&M, we see how it has, I'm going to try to hold it to the camera, an M on it. So when you drop it in the water, that M is actually supposed to float off of the M&M into the water. So that's what we're going to try to do today. So I'm going to take a couple different colors. Does anybody have any specific colors they want me to drop?
Red.
Red.
Blue.
Blue. Oh, we're falling. All right, I'm going to do red, blue, and green. So I'm going to turn the camera.
Do you want us to do that?
Yes, if you have the materials, please do it. Maybe if I can switch the camera. Oh, found it. Did it work?
The screen's black, Julie.
Oh, I know why. Okay. All right. So I'm going to drop the red M&M in it. Oh, it floated. And as we can see, the red's kind of already starting to come off of it. So then we have blue. We have red and blue, so we can already see that the red's kind of falling off. And then we'll do a green. All right, so we have that. So after you form a hypothesis, I'm going to let that kind of soak for a second. Our next step is we actually do the experiment. So that's what I just did. I dropped the M&Ms inside of the water. And then after you do that, you kind of have to analyze and see the results. So I'll turn it back over and we're going to watch it and kind of guess on some things and guess like why some things are happening. And then after that, the last step is where you actually have to reject or accept your hypothesis. So that means if you accept it, that means your hypothesis was correct. But if you reject it, that means it was wrong and you can redo the experiment. So the scientific method, it can sound kind of intimidating, but we do this naturally to solve problems. So you do this with math problems or any kind of sticky situation that you find yourself in. So we're going to look at the M&Ms. Now, tell me what y'all kind of see.
That's cool.
Do y'all notice anything?
I noticed that it's turned into a lot of color.
Yes, and the colors on the M&Ms are dissolved. Do we know what dissolving means?
it's toning, like it's dissolving out, so it means that the colors is disappearing.
Very good. So dissolving means it's like broken up or absorbed. So the color on the M&M, it is falling off. It is breaking apart. So in this case, it's breaking away from the colored shell. So I know y'all didn't get to see it because I was had the camera turned around. But if you notice, the red and the green color is actually
Julie, we cannot hear you anymore.
okay.
There we go.
Does that work? Okay. Where was that? Okay. So the reason that they dissolve is because the M&Ms, like the color of it, isn't afraid of water. So that's why they're dissolving kind of quickly. So, but eventually we're going to be able to see that the chocolate doesn't dissolve as fast as the color. So some parts of the candy are water soluble, but some are not. Now, that word soluble, does anybody know what soluble means? If I said that the color is water soluble,
What about you, Bri? You know what that means? Probably. No, looking at it. What about you, Jaden? Nope. Someone want to
Okay.
make a guess?
yeah, anybody want to make a guess if it's water soluble, the color?
They're like absorbent, like the water absorbs the color.
Yes, basically. So soluble means it dissolves in the water. So very good. The water is absorbing that color. So some of the things on the M&M is not water soluble, and that's why it does not dissolve as quickly. So the water molecules are able to surround the molecules on the M&M and kind of dissolve it into the water. So as we see, we actually see the M has floated off of one of the M&Ms. So when we talk about the M&M, it is made up of molecules. Now, does anybody know what a molecule is? I know that's a big word, but basically a molecule is a smallest unit of a substance. So a molecule is made up of small particles called atoms, and these come together to form, excuse me, a molecule. And these molecules come together to form bigger things. And sometimes we can't see it. So for example, we can see these molecules all around us. So we can see it in water. We have some sand on beaches, dirt on the ground. So all of those have molecules in it, just like this M&M did. So the M&M, it might have broke, oh, there it is. Can you see it? Trying to get to focus. Yeah. So the M&M kind of soon starts to float off. And this took about 10 minutes on the red M&M. Let me look at it. Yeah, I can kind of still see the, well, maybe, there it is. The M still on some of them. So the M actually floats, is the only thing that floats free from the M&M. Can anybody take a guess why they think the M&M came off of, the M came off the M&M?
Because it has more molecules than all the other ones.
Okay, that was a very good guess. So the M is actually edible paper. So when you think of paper, you think of like paper like this, but edible paper is paper that you can actually eat. So we see this on cakes if it has like a picture on it, or cupcakes, and the M on the M&M is edible paper. So we can eat this. It's completely safe to eat. But the reason why the M doesn't dissolve in the water is because it is not water soluble. So it doesn't just dissolve and go away. That's why it just kind of floats free. So after we look at it, you can kind of start to see that the colored shell comes off of the M&Ms. And then now we can see the chocolate of the M&Ms. Well, it's having a hard time focusing. All right, maybe. So we can kind of see from this experiment that we had the colored shell of the M&M kind of float off and dissolve into that water. Do we remember what dissolve means? Let me see here.
Dissolves means it starts to disappear.
Because it is not water soluble. So this is something that's super easy that you can do at home. I will tell you that if you leave the M&M in the water for a long time, you can actually see the chocolate on the M&M kind of do some stuff. I haven't been able to get around to that before, but I think it takes a little while to do that. But if you do all the colors of the M&M, it all kind of floats together and you see how they're kind of mixing together, the red and the green and the blue. So I will say, I know it was kind of hard to see. Did y'all see any colors that floated off faster or slower than the other color?
Red.
The red, yes, very good. The red actually, as soon as I put it in there, it actually dissolved very quickly. And the blue took a long time to come off. But we have that one M right there floating around. And I know if you do all of them at once, you're going to see some different reactions to the water. So there might be another color that's slower, that dissolves slower than the blue, or maybe there's even a color that dissolves faster than the red does. But that's something to see. Yeah.
I put a brown one in there and dissolved. It dissolved faster than the red.
The brown?
Mm-hmm.
Ooh, can you show us yours, Aiden? And if anybody else did it, show us yours too. Did it work for you, Aiden?
Yeah.
Oh, yeah.
I put a brown and a red in there. It'll make it take a few minutes.
Did your M float off? Of
The
your
brown
M&M?
one. The brown one started to go now.
The brown one did?
Yeah, it started. See? One more one.
Oh, yeah, it did. And those are mixing together, yep. Very good, Aiden. All right, so let me turn this around. All right, so I know this was pretty quick, but if you do it with more M&Ms, it's going to take a little longer because some of them actually dissolve slower. So I think it was maybe a yellow M&M the other day, and it took a long time. But I encourage y'all to do that, try it out. But before we kind of end, let's talk about our hypothesis that we made. So that's our last step. Our last step is where we reject or accept our hypothesis. So in this case, we said, a few of you said that the color floats off of the M&M. So were we able to reject that? Did it happen? Could we accept it, or did it not happen? So did we see the color kind of float off of the M&M? Yeah, and then we even got to be able to see the M come off of the M&M. So that's just something that's quick and easy for y'all to do. Okay, I thought it was gonna freeze. But this is the M&M experiment. I encourage y'all to so if you're gonna do all the M&Ms, I wouldn't use something as small as the mouthwash cup, because you can see with the 3 M&Ms that I used, it was kind of already cram packed. It's about to storm here. So when you do it, I encourage you to set a timer on a phone or some sort of device that you have and write down and see how long it took each M&M to actually dissolve and that M to float up. So is there any questions about this experiment?
My M started to float out. The brown one did.
Your M did? Oh yeah, look. So see, your yellow and your green and then your brown and your red. It's all like kind of cornered off together.
The brown was the first one.
The brown was the fastest. That must be pretty fast because that red floated off almost immediately. Was the yellow kind of slow or did it go fast? It was slow. Yeah. All right. So is there any questions about like some of the terms we talked about, like dissolving or water soluble, kind of what that means if you want to review it? All right.
I'm now testing the orange to see how fast it goes.
Testing the orange. All right. See, this is actually something really simple and cool that you can do. I got these from Walmart. They were like 90 cents. And then I had water at my house. And then you can use any sort of cup or bowl, container. I think I saw Aiden had a tablespoon. You can use anything like that to put these M&Ms in to look at. So it's it's something simple and it's kind of quick to do and it's fun, and you can act like a scientist and do those steps that we talked about. Remember, like doing an observation, making that hypothesis, doing the experiment, kind of looking at results, and then accepting or rejecting your hypothesis. So when you reject your hypothesis, that means you can actually go back and start at step 1 and redo the experiment. But luckily, we didn't have to do that because it worked this time for the M&M. So I hope y'all enjoyed it. Is there anything else that y'all have questions about?
I noticed that the orange is the slowest one.
The oranges? Oh, yeah, it is. See, I see your M's floating. All right, well, does anyone have anything they want to say?
Girls, won't you tell Miss Julie what was your favorite part about the experiment?
Mine is that when they're done, getting the color off, it makes a pretty design at the bottom.
Mm-hmm. Yeah, it was interesting seeing the colors kind of mixed together. That was cool. Kind of make a rainbow.
The end's floating off of them.
The M float. Yeah. I didn't even know it did that until I did this. I tested out this experiment the other day, and I didn't even know it was going to work. So it was pretty cool.
I just sticked my finger in it and twirled it around, and it looked cool because the colors went everywhere.
Mm-hmm. I think you should be able to stick your finger in. My M broke up because I put more M&Ms in it. And I think you can actually take that, if you're careful, you can take the M out of the water. But my M broke. I tried to do it and it didn't work. I wasn't very careful with it.
Carissa, what was your favorite part of the experiment?
The M coming off.
Them coming off. Yeah, that was pretty cool. What about you, Jaden?
All the colors mixing together.
Yeah,
Mm-hmm.
look very artsy.
Yeah.
What about you, Miss Leandra Lanaya? I think they ran.
And seeing everybody.
Yes, and seeing everybody. We are so glad we got to see all of you all and join in and have fun. So I hope that you all get to do this experiment at home. So it was fun. Any last questions?
I can show you the design that mine made. I put all the colors in it.
Oh, wow, you mix all the colors together. Did it make brown? Oh, can't hear you, Aiden.
It's like an orange. It's
Emily,
an orange brownish.
What were we saying, Carissa?
What, Krista?
What were you saying, Carissa?
Say hi to them.
no.
Carissa, what did you say?
All right, girls, I think that is it. And so we're gonna keep Miss Julie on here, okay? And we see you all later, okay?
Bye, girls.
Bye, girls.
Thank you.
Bye, girls.
Thanks. Bye. It was good seeing you. I'm afraid it's gonna start raining.
Bye, Jaden.